Hi everybody, I'm Matthew, and this is True North Geography. Welcome to the Badlands in Alberta. We're going to talk about how these rock formations behind me formed. Today, we are looking at Badlands. These are heavily eroded landscapes that have subpar agricultural value and are generally unsupportive to human settlement. So if the lands are so bad, why do they look so damn good?
Badlands are found throughout North America, but are most abundant in western Canada and the western United States. When you look at a map of the regional geology of these areas, you find that these badlands form in sedimentary bedrock, including sandstones, siltstones, and shales. These rocks are easy to erode, allowing for rapid downcutting over geologically short periods of time.
Now you may be wondering, if all the rock was of the same type, wouldn't downcutting be fairly uniform over the landscape? Intuitively, this makes sense, but it rarely happens in nature. What we actually see with sedimentary deposits is that we have weaker rock layers, or strata, interbedded with stronger rock layers. When these deposits are eroded, the stronger layers slow down the downcutting for a time, preserving the weaker layers below. This process is known as differential erosion. This process also occurs on a small scale with the formation of hoodoos. If you look at a hoodoo closely, they are always topped with a more resistant cap rock. Eventually, though, the weaker rock below is cut from the sides by sandblasting or attacked by frost wedging, causing the hoodoo to collapse. So how the heck did all this rock get here anyway?
That about sums it up. During the Cretaceous period, or approximately 143 to 66 million years ago, sea levels were significantly higher than they are today, and a large seaway, known as the Western Interior Seaway, covered much of what we now know as the Great Plains and the prairies. At the same time, the Rocky Mountains were in the process of being formed, and material eroded from these young mountains formed thick deposits in the seaway. Different rock types were deposited in different parts of the seaway. In coastal and nearshore areas, sandstone was deposited. Slightly deeper, mud was compacted and lithified to form weak shales. And in the deepest parts of the seaway, where sand and mud could not reach from land, limestones and other carbonate rocks were formed from dissolved calcium carbonate in the seawater. But the boundaries of the sea did not stay static. Over time, the sea grew and shrank until finally disappearing around 66 million years ago. This ebb and flow of the seaway changed which rock types were deposited at a particular site over geologic time. To unpack all this complexity, geologists apply rules like Walther's facies law to data from geologic surveys and rock cores in order to describe or interpolate the distribution of rock layers in 3 dimensions. However, the main thing to understand here is that any particular site, the growing and shrinking seaway deposited different rock layers at different times, with each rock layer having different levels of resistance to erosion. Now, since all this happened during the Cretaceous, the Badlands in Alberta and Saskatchewan are some of the best places in the world to find dinosaur fossils. Sites like the aptly named Dinosaur Provincial Park have yielded incredible finds, allowing us to understand the dinosaurs that inhabited Laurasia during the Cretaceous. The best specimens are on display at museums across the prairies, including the Tyrrell Museum near Drumheller and the Royal Saskatchewan Museum in Regina.
All in all, the Badlands are one of the best windows into geologic time anywhere in the world, allowing us to understand everything from ancient seas to dinosaur fossils. We hope you enjoyed the video, and if you want more content like this, be sure to like, subscribe, and hit that bell button. See you in the next video.